Hello everyone, I am Karthik Mansali. Welcome to my YouTube channel. Not subscribe to my YouTube channel, please do subscribe and also like the video so that I get motivation to do more videos. So in previous videos we have already discussed about types of relation. That too in trivial relations we have covered the relations and cell relations, and in previous video we have completed the reflexive relation definition and examples. If you not watched those videos, please check my description. In description I have mentioned the playlist so that you can click that link and you can watch those previous videos. So in this particular video today we are going to discuss about symmetric relations and some examples. Okay, so let us define the symmetric relation. So word itself symmetric, here the word itself says symmetric. So we already know the word about symmetry. If you take any shape or a piece, if you cut into two parts, if those two parts look similar, then we call it then we call both are symmetric to each other. So for example, if I consider a triangle, if I cut this triangle into two parts and I named it as a left part as a A and the right part as a B, then this A is symmetric to B and this B is symmetric to A. These A and B two parts look similar, so it means A is symmetric to B and B is symmetric to A. So in relation A is related to B, then indirectly B is also related to A. Then this relationship is nothing but a symmetric relation. So if you consider square also, and cut into two pieces, then it becomes A and this part becomes a B. If A is symmetric to B and here B is symmetric to A. In same way in relation, if A is related to B, then B is also related to A. It means this type of relation means mutual relation. A is also have some relation to B and B is also having a same relations to A. Then this relationship is nothing but a symmetric relation. Okay. Definition also says the same thing. If for all, so here using the symbol for all, A comma B belongs to R. If for all A comma B belongs to R, then B comma A belongs to R. A comma B belongs, order pair A comma B belongs to R means here A is related to B. Okay, then same relation it has to be also B is related to A, then B is also related to A, means if A having some relationship with B, that then B should also have the same relationship to A itself. Then this relationship is nothing but a symmetric relation. If A is related to B, then it has to be B is related to A. If B is not related to A, then it is not a symmetric relation. Means A is related to B, A has some relationship with B, but B is not having same relationship with A, then obviously it is not a symmetric relationship. Both sides having no similar relationship. Okay, so this is what definition says. So let's move to example, then we can clearly understand the symmetric relation. Okay, so in example, in general we say siblings relation. Siblings relations are we can match to a symmetric relation, because if A is sibling, A is sibling to B, then obviously B is also sibling to B. Sibling means either brother or sister. Okay, so if A is a sibling to B means definitely B is also sibling to B. So it means sibling, for sibling relationship we can say it is symmetric relation. Can say symmetric relation. For reflexive relation we have used a friendship relation. So here we can't use a friendship relation, because if A is friend to B means B may not a friend to A. Sometimes A is a friend to B, but that B is not friend to A. So friendship relation sometimes it is not mutual. So sometimes it doesn't work from both sides. So friendship relation doesn't work for symmetric relation. Friendship relation purely work for reflexive relation, because a person can be friend to himself. So sibling relation is best example for the symmetric relation, because for symmetric relation there should be a two elements A and B. If there should exist a relationship from A to B, and also same relationship, there should exist a same relationship from B to A also. So it works only for a sibling relation. I think if you know any other general relation, you can comment me in video, okay, so that I can also get those examples. So in mathematics, let us understand same. Let us take the set 1 2 3. Okay, 1 2 3. I am considering a same example 1 2 3, and I am creating a relation R1 here. So if I not create any relation, if I made it as a R1 empty, so let us revise all previous types. Okay, so if R1, if I create a R1 as a empty, means I have not created any relation, so then R1 becomes empty. Then obviously this is which relation? Empty relation. This is empty relation, we have already discussed in previous videos. So if you not watched, you can go to description, I have mentioned their playlist. Okay, so R2, I am considering R2. So in R2 I am creating a relation 1 comma 1. Okay, next 1 comma 2, 1 comma 3, next 2 comma 1, 2 comma 2, 2 comma 3, and 3 comma 1, 3 comma 2, 3 comma 3. So I have written all possible relations. If I written all possible relation, means then definitely this is A cross A, because A cross A is a Cartesian product. Cartesian product means Cartesian product contains all possible relations, all possible ordered pairs. Okay, now I have written all possible ordered pairs. Then this R2 becomes now universal relation. Universal relation. And also if you apply this R for a reflexive definition, see here 1 comma 1 is present, and 2 comma 2 is present, and 3 comma 3 is present. So it means every element of A is related to itself. This is the definition of a reflexive. So this R2 is also reflexive relation. This R2 is also reflexive relation. Okay, so if you apply R2 for a symmetric relation definition, then obviously see here 1 comma 2. If you consider some element 1, now I will consider 1 comma 1 belongs to R2. Okay, 1 comma 1 belongs to R2. If we reverse 1 comma 1 also, then it becomes 1 comma 1 belongs to R2. So there is no problem. Next 1 comma 2, I consider 1 comma 2 belongs to R2. Okay, 1 comma 2 belongs to R2. Now I will reverse the 1 comma 2, because to check symmetric relation, if A is related to B, okay, then that B is also related to A. B should be also have a same relationship to A. So I am checking 2 comma 1 is present or not. R2, it is R2. Okay, 1 comma 2 belongs to R. So here 1 comma 2 is present in R2. So 2 comma 1 is also present. So 2 comma 1 is also present in R2. So now let us come to 1 comma 3. 1 comma 3 belongs to R2. Okay, implies 3 comma 1. Check the 3 comma 1 present or not in R2. Yes, 3 comma 1 is also present in R2. So 3 comma 1 is also present in R2. Next, verify 1 comma 3 has finished. 2 comma 1, okay, 2 comma 2, 2 comma 3. Now next consider 2 comma 3. We have to check for each and every ordered pair in relation. Each and every ordered pair in relation should have a reverse also. If you consider A comma B in some relation, then B comma A should be also present in that relation. If we not found any one that type of relation, then it is not a symmetric relation. We have to get each and every ordered pair. Okay, so 2 comma 3 belongs to R2. Okay, implies 3 comma 2, verify 3 comma 2 is present or not. Okay, 3 comma 2 is also present. 3 comma 2 belongs to R2. If I consider 2 comma 2, if I reverse 2 comma 2, then obviously 2 comma 2 is belongs to R2. If I consider 3 comma 3, if we reverse 3 comma 3, same 3 comma 3, it looks like a 3 comma 3. So it implies 3 comma 3 belongs to R2. It means each and every ordered pair, if we reverse the order pair, it means if we interchange the A and B, then the relationship should present in R. Okay, so I take another example, R3. Okay, in R3 I have mentioned 1 comma 1, 1 comma 2, 2 comma 1, 3 comma 2. Okay, so if you consider this 1 comma 1, if you reverse 1 comma 1, okay, so 1 comma 1 you will get. If I consider 1 comma 2, if I reverse 2 comma 1, so it is present in R3. If I consider this 2 comma 1 and reverse the 2 comma 1, I get 1 comma 2, so it is obviously present in R3. But if you consider 3 comma 2 and if you reverse this if you reverse this 3 comma 2 as a 2 comma 3, which does not belongs to R3. Here we should write here 3 comma 2 belongs to R3, but 2 comma 3 does not belongs to R3, then it is not symmetric. Then it is not symmetric relation. Then it is not symmetric relation. So not symmetric relation, when it will be not symmetric relation means if there should be A comma B in relation R and there should not be present P comma A in relation R. A comma B is belongs to R, but B comma A does not belongs to R, then this is nothing but not symmetric. Not symmetric. A comma E is belongs to R, but B comma A is does not belongs to R, then it is not symmetric. Easily we can find if we should consider one order pair and we should reverse that order pair, because if A is related to B and we are verifying for B is related to A, we are verifying for B is related to A means we have to reverse the order pair. For example, if in this example R3, so 3 comma 2 is belongs to R3, but if we reverse this 3 comma 2, it becomes 2 comma 3, but this 2 comma 3 which is not present in R3, so it does not belongs to R3, then this is not a symmetric relation. And also it is not a reflexive relation, because here 1 comma 1 is there, 2 comma 2 is missing, 2 comma 2 is does not belongs to R3, 3 comma 3 is does not belongs to R3. If any one of the element is not related to itself means definitely it is not reflexive relation. So R3 is not symmetric as well as not reflexive relation. So now onwards, if you consider any one example, if you consider any one relation, then we will check for reflexive, then we will check for symmetric, we will check for empty, we will check for universal. Each and type of relation we have to verify, because if we apply each and every type of definition to that relation R, then we are going to get it is reflexive or not reflexive, we are going to get it is symmetric or not symmetric. Okay, I hope you all understand this symmetric relation definition and example. So in next video, let us try to understand the transitive relation. After completion of these three, so now in previous video I have completed reflexive relation, just a definition and example, some example, and now we have completed the symmetric relation definition and some example. In next upcoming video I am going to cover definition of a transitive relation and some example. After completion of these three types, particularly these three types are the important in relation. So now in upcoming videos I am going to combine these three relations and solve some problems, so we can expect 3 marks from these three relations. So by combining all these types, let us solve the problem, then we will get we will get some good practice there. Okay, up to then, bye bye.